Hey everybody, here's a little optical encoder circuit I used. I want to make a 3D printer using those InkJet shuttles because they're really quiet, they can be really fast, they're really cheap, and they're getting thrown out all the time. So I found that I was missing steps by putting a little piece of paper here, post-it note, and just running back and forth thousands of times. And at first you think, man, I'm not missing any steps, it looks perfect, but eventually the shuttle gets misplaced. It doesn't go back to where it started. And I finally figured out using why it's doing that when I'm using pulse width modulation with optical encoders. And I think this applies to Arduino and some of the others. I know it applies to MSP. And I've seen a lot of comments. And let me show you the code. I've seen a lot of comments showing this problem on internet, and I don't think anyone has really found the solution that I have found. And a lot of people have done this. In their interrupt code on the optical interrupt, there's two encoder lines for two optical encoders on these guys. And when encoder B line turns high, what you can do is check if it's already high from the previous setting. And that means you're getting noise into the encoder. And if you get noise, just return and don't increase the count. And count is only increased or decreased based on the other encoder's line, which was previously interrupted and set. And what I'm doing now is to find this is I turn an LED on when this noise is detected, and when it's detected I just return, but then as soon as the other interrupt comes in, whether it's A or B, I turn off the LED right away. Okay, so you should see a little pulsing on this LED if you're getting this noise that I'm finding. And here's a little LED shown right here. It's barely flickering on. I'm going to turn off the lights for a second, but you can see that LED turn on and flicker. And I've noticed whenever that LED is on, eventually I miss steps. And you may not miss them for a long time, but on a print job, you will notice it. Your 3D object will drift. And you can see already that the paper isn't where it was at the beginning of the video. There's a little space between the pink and the black shuttle's edge. See if I can zoom in here. Yeah, so see that little gap on this side? The lighting would cooperate. There you go. See that gap between the paper and the inside of the shuttle? That should be 0 length. It's already drifted. So here's what I've noticed why I'm getting the noise. And I think I can solve it if I need to isolate the motor from the rest of the circuit. And what's happening, let me show you here. I found another motor that's very similar, and I hooked up the leads to this motor instead to see if the pulse width modulation would cause this noise with a different motor, and it didn't. And another thing I should point out, and this is very important, it only happens with pulse width modulation. It doesn't happen if I turn the shuttle full on or full off. So now if I let me turn this off for a second and reconnect this other motor, I won't get that light turning on anymore. Now the motor's turning, and it's not turning back and forth like the other one because the optical encoder is connected to the shuttle. So I have to manually move it, and then the motor, you can see the torque is changing direction on the motor. But when I'm doing this, I'm not noticing that light turn on, and I'm not getting, so that means I'm not getting into this noise condition here where it's detected a rising pulse when it's already risen. So the problem with interrupts is you can do them if they're changing on the voltage line, either rising or falling, but you can't have separate interrupts for rising and a separate interrupt routine for falling. So you have to do just changing when you enable your interrupts, and then here you have to check, where did it change? Did it rise or did it fall? So um, here it's rising, the interrupt is rising, and so if it's already risen, you've got this noise. So now I'm not noticing any noise when I do this on another motor. However, if I take this motor and I touch it to the chassis like this, my flashing LED turns on right away. Just if I touch the motor on here. I've measured voltage in between this can and here, it's 0. I've measured voltages between each lead and here and each lead on here on the can. Basically, I've tested resistance from everywhere. There's no short to the chassis or anything. So it's some kind of EMF or something that I just don't know what it is. But I think if I isolate the motor from this metal, then I won't get this noise, and the shuttle will always return exactly to where it's supposed to be. And let's see what else. Oh, I also touched the motor to the chassis with a piece of paper to make sure it wasn't just vibrating this encoder and making the noise from just vibrations. And sure enough, the light never comes on with the piece of paper in between, so that noise isn't happening. And let's see, what else did I try? Like I mentioned before, this only happens with pulse width modulation. I had a PID going into this motor because I need to stop gradually before hitting the paper, otherwise the shuttle overshoots with the inertia, and that would not be good for a 3D print. So I think I'm one step closer to getting this working for 3D printers, and it's been a long journey. I'm using the L293D motor controller, which is a pulse width modulated from TI, and I don't know if it's supposed to be pulse width modulated. Maybe that's part of the problem, but the noise is actually coming into the interrupt pin on the microcontroller. So if you have any ideas, put them in down below, and I'll continue to work on this. So I hope to get an extruder and 2 axes built off this thing, this concept. Okay, I think I found a solution. I'm not quite sure why it works, but I've been running this for about 45 minutes and it hasn't deviated at all. It's barely hitting the piece of paper, just like I set it up to begin with. And what I did was I just simply grounded the chassis to my encoder and the rest of my microcontroller, which looks like a mess, but I tried all kinds of other things, including extra capacitors on everything, and that didn't work. I tried putting diodes to increase the voltage threshold of the rise of the voltage line from the encoder to the microcontroller. That didn't work. But this really works. There's no flashing on that LED anymore. Every now and then I'll see a little flash, but I think it's because my wire is a little loose. I hold it on there like I am now. There's no flashing at all. Oh, that was a flash. I saw a flash. But even with that occasional flash, here, watch, I'll take it off totally. Watch the difference. 1, 2, 3. Okay, it's off. Now you see it flash all the time. And maybe this isn't sufficient. Maybe I need to do something else. Let me know in the comments if you know what else I could do. I don't like this occasional flashing, but it hasn't deviated, so that is good. It's one step further. All right, guys, talk to you later. Let me know if you have any more ideas. Bye.